I'm going to introduce you to John McGowan, who you may have heard of. He was the creator of GMath, the GMath add-on, which we acquired, I think, in August of last year, along with John. So John is now a text helper. We like to call him the STEM text helper. And he has been helping us along the way, building out EquatIO, letting us know what math teachers need in a product like this. And so we're really excited to have him on board and get his feedback on what we can do for the math class to make it digital. And so if you've used GMath before, you'll see a lot of similar features in EquatIO, but you'll also see a whole lot more. So with that, I'm going to turn it over to John, who can tell you a bit more about the product and then give you a demo.
Awesome. Thank you, Dina. I really appreciate it. And I am super excited to be able to talk about EquatIO. It's something that's been coming along since I joined back in August. I'm overjoyed every day when I get to do the demo. It's super fun. And I can't wait to do the full build and show it with everybody. So essentially, what is it? We have a great quote from Emily Fitzpatrick from EdTech Team Canada. And that essentially, it's everything that I want as a teacher. What can I make to do with Google? How can I use this awesome collaboration tool of Google Docs and the quick assessment from Google Forms and still use the power of math? And then also we're expanding it up into all the STEM fields, and we're going to continually roll that out and iterate and add more on that part. So that's the whole goal, is to just make it easy and fun to create digital math. My goal is actually to make it delightful and intuitive, and I think we're getting much closer to that part. So why do we build EquatIO? So GMath I was so surprised how that took off, and if you're familiar with it, that's awesome. It's really like amazing for me. I learned how to code just so I could have my students use Google Docs, and then it took off from there. And it still has this ease that it doesn't exist yet due to some other requirements. So we built EquatIO. It's kind of like GMath growing up, and if you don't know GMath, that's fine. But EquatIO, if you do know GMath, we built in almost all those same input tools. So math and STEM subjects have been left behind going digital. It was hard to type math. It's hard to represent things digitally in math and science, and we're trying to change that. And then that's the hard part, is that technology is this amazing thing. I mean, Chromebooks coming into the classroom are cheap. That makes them ubiquitous. Students have devices, and then they just can't use these devices in the classroom. So we want to make sure that technology can actually enhance learning and not be this barrier. There's an accessibility issue. So text help's amazing with the read and write, creating accessibility. And I felt like math is an accessibility problem. Like, it's hard to make it digital, and so that's why text help's been super amazing, because they have a vast experience in making things accessible. So I'd love to join up, and we're making math and STEM accessible now too. And then finally, we're shifting from, so if you use GMath, it's an add-on for Google Docs, a separate one for Google Forms, and another one for Google Sheets. And so the problem with the add-ons is they are contained only within that add-on. And so it looks slightly different based on what you're doing, and that's confusing for students and for teachers alike. And so we wanted to make it, now we're going to do a Chrome extension, so it's the same thing, the same experience no matter where you're using it, and it also gives us the power to move outside of Google Docs and Google Forms. So that's the reason why. So we can build out and do some other things that are not just in Docs and Forms. And so quickly, let's break it down. It's going to be a Chrome extension. It's this super cool little, it's built upon the Penrose triangle, so I'm super excited by that. It's a little rectangle thing, and it will have Google Docs and Forms integration when we launch on April 4th. And the best part is it's going to work on Windows, Mac, Chromebook, no matter what. If you're in the Google Chrome browser, it works best. And so we shift a little bit from GMath, and we want to build it on these full UDL principles. So what does that mean if you're not familiar with it? I admit I wasn't super familiar with it before starting to talk with Martin, our CTO, and start talking about accessibility. And the more I learn about it, the more I think it's just a natural way to teach. Like, you're trying to reach every student, and we all have our inherent learning styles, and as teachers we're kind of biased. We teach in the style or the manner that we learn best, and that's not always the way that students do. And so we want to make it easy for students to create and consume math and STEM content in the manner that they prefer. So whether it's with prediction, handwriting recognition, speech input, if they know LaTeX and want to use that, that's great. So we want to make it so they can create or consume it however they want. And then we make it digital, and as a teacher, I can then consume it in the manner I want, but I can also create and consume in the same way I like to. So that's the beauty, is that my learning style and my students don't have to be the same, but yet we can still find this common ground of digital and then make it so we can both enjoy the content in a manner that we prefer. We also link up with Read and Write to do map to speech, and then we also can do we can read that aloud, make that accessible, because that's great, because typically it wasn't accessible before now. And then we also have our first STEM part. We're going to have some chemistry part in here, so I'll show that a little bit later. And then we're going to be continually launching more and more STEM options. And this summer we're going to have add on to EquatIO to be a much more rich environment. And I'll talk about that a little bit after the demo. Great. So the big thing is on April 4th, we're going to launch in docs and forms. And so from there on, we're going to be constantly building some of the things out, and I'll talk about after the demo where we're going to move from that. But essentially, let's see, first off, it's just going to start off as an extension. So let's say I'm just in a normal Google Doc, which Google Docs shifted my entire perception as a teacher. I used Doctopus, shout out to Andrew Stillman's amazingness, to share out a doc. I put some math problems in a doc and shared it out with my class. And I had a class, I put some kids in groups and had a class edit document. And I had a girl who never said a word in class. She was brilliant, but never, her voice just didn't come out. It was very mousy. You had to literally almost put your ear to her mouth to hear her say something. And when I shared a document, she was a voracious commenter. She was like, I had to go actually walk back to her computer and make sure it was her and not somebody hacking her account. And that shifted my whole perception of teaching, giving this new medium of Google Docs. So the beauty here is this EquatIO will allow to make it digital and work in these docs. So as a Chrome extension, all you do is have to click the button when you're in docs, and it launches the nice little toolbar down here at the bottom. And so we have 4 options of ways to input math. So the first one is our equation editor. And so as we pop that open, we can actually even drag this open up and more. So that's one beauty of how we moved out of the sidebar. We actually have much more space here to work horizontally. So I'm really excited by having that extra space. You might also notice, if you're familiar with GMath, here's these little pre-populated ones that we have if you want to use those. But our goal is that you won't need to know any of these shortcuts, because now we have math prediction in here. So let's say I want to type like 3x squared, but I don't know how to make the little squared thing, how to make it up into the superscript. If I just type SQ, then it's going to predict which I want, so which of these math terms. So if I click on squared, then it actually makes and puts that 2 up in the superscript. So awesome. You don't need to know the shortcut. It still works if you know that Shift 6 to make a little caret moves you up in the superscript, but you don't need to know that. I've also found that like PL for plus is like super awesome, and I'll pop that in there. And if I use that PL and hit enter much more frequently now, because it's very difficult for me to stretch with my pinky to hit the left hand to hit shift, and stretch to put the plus sign. So I hardly ever use the plus key anymore. So I can just, as I want to do that, I can just use these prediction parts to end up typing in there. So even like EQ for equals 0. So once I have that typing part, I can just insert that math, and it automatically puts it into my doc wherever I am. And then now that that's made, I can actually jump to Read and Write, and have Read and Write will read that aloud as it should. So
3x squared plus 4x plus 4 equals 0.
And I'm not sure if you could hear that read out because it's coming out of my machine. So I think it should, but could you guys hear that? If you couldn't, it read it out loud. So let's see.
We could hear it, John.
Okay, great. And so now on that part, why did this keep popping up? There we go. So that's the beautiful way to use prediction in there. And so if I want to get rid of something, I can delete it. I can also extract it. So I just click on it, hit extract, and it'll populate it in there so I can edit. So anything I make, I can also edit as well. And so what other prediction things do we have? So we have some formulas. So like typing QU, I get quarter quantity, but also like quadratic formula, quotient of powers. So I hit that, and it automatically enters in my quadratic formula. I'm so excited by that, because that will enable my students to be able to show more thought process, because it makes it easier for them to type that in there. So I'm so happy that we have these things built in. So I can also, beyond those, like we have a standard library of things. So if I had standard deviation of a sample, standard form of a linear equation, standard form of a quadratic, so lots and lots of different things in there that I can put in. But not only that, we also have chemistry options. So if I start, all of our chemical compounds are built in there. So like aluminum triacetate with subscripts and parentheses, not super easy to make, but I can instantly insert that in for my chemistry. So that chemistry prediction is the first component of that STEM feature that we're building into there. And we're going to constantly be adding more and more features for physics equations and things that we might need to use in biology and all of these types of STEM objects that make it nice and easy to do. So I think that was really awesome, that prediction part, where no longer do we have to hunt and peck for the button to click to make sure I put my stuff in there. So every other editor, equation editor, is what we call palette-based, where you have to find the correct button and then click on it first, and then when I do, then I can find what I want and put it in there. And that's not necessarily a very easy thing, especially if you're trying to learn what a square root is. You might not already know what the square root looks like. So you can literally just start typing SQ and then find that square root, and it'll make it for you. We also have coming down the line a Spanish prediction, so you could just start typing RA for raíz cuadrada, and then that would give you the square root sign, and then you can, so that's super awesome for students who are English as a second language or Spanish speaking to be able to make that connection. So we also have a LaTeX editor, which I don't really want to demo that part because my goal is to move you away from LaTeX, but it's pretty cool that if you have some LaTeX in there, you can actually edit on this side as well. So if I edit on this side with my normal simple editor, it'll show me what the LaTeX is. So if you're trying to learn LaTeX, that's a nice way to be able to do that. But I don't want you to ever have to use LaTeX again. So let's go ahead and look at what our handwriting component looks like. I'm super excited by this handwriting. Now I'm showing you on what is not my touchscreen, and so I have a touchscreen, which is, it just makes it beautiful, but the handwriting here is still okay. Do it with just my mouse. So my handwriting is not good. But you can see here as I handwrite it, it thought that that was a 5, and so you can even like correct it a little bit and make it a 3. And so, oh, that was bad. And let's see, so we'll just start over with that 3, so we'll make it a 4. So it'll automatically recognize that, and it can even do some complex things. So I can make it have a square root of 3 in there, and then I can come over here, and if it's possible for me to edit with my simple part, I can. So I can just edit over there if I want and put it in there. So the cool part, though, is that's handwriting that goes to our recognition component. I'm not going to edit it yet, but if I insert it in there, now I just went from handwriting to be accessible. So if I would, pull this down and then have read and write, read that aloud. Let's see if it wants to do that for me.
4x plus 12 over square root of 3.
So I'm super excited about that combination because it literally goes from a real-world handwritten thing to accessible. So that's the power of technology right there to make something accessible that previously wasn't. So like I said over here, if we have this little guy as green, that means that we can edit over here using our simple part. So I can even just say like equals 4 over 12 if I want on that, and then insert that component. But that's a really cool part that I can edit on that. Now I can actually, if I wanted to, add over here some other handwriting stuff, and it'll continue editing on the end of this. So I can use the handwriting in conjunction with my editing. So that's really fun and cool. But another thing that I love is the speech input part. So the speech input, it'll start to record all of my things. So if I click, then the speech input will, there we go. The speech input will try to determine all the things that I'm saying and filter out non-math terms. And so I can actually edit that, either the things that it interprets, or I can edit in the math. 3x squared plus 14 equals 10. So when I pause that, there's a bunch of ands and i's that those will be gone when we launch in a week and a half. But I can also just edit those out over here. So if I want, I can edit them out here, and then it goes over that part. Or if I wanted to, I can square root of 4. I can actually interpret it over here as well if I want. And so like let's say I wanted a 6. I can even type in the letters. So you can literally read out like a problem. Maybe you had a word problem of like 3 cats and 2 dogs. If I did that, 3 cats plus 2 dogs, how many legs are there? So if I said free cash, that's all right. I can just say like 3 cats, and plus instead of $2, I could say 2 dogs. But either way, so it can interpret some of that math in there. So I think that's a great way to recognize, especially for students who can't understand yet as they're learning a new topic. They hear all this new vocabulary, they can literally just speak it. Like a square root of 4, who knows what that looks like? Square root of 4. Then they can write that, they can insert that in there, and then it will actually read it aloud as well. So those are like this amazing component of going from speech to digital and then being able to be read back in there. So that, I think, will really make ideas more concrete for students and enhance that learning for them to have like a multimodal display. Okay, so I'm super excited by that. Those are all the options that we have in currently when we launched to be able to make math digital. So that's great for Google Docs. Now for me, the amazing part and the magic comes when I launch the Forms part. So let's jump on over to Forms and I'll show you the same thing. So in Forms, we have a great part in here. So I think I lost my Wi-Fi, so let me reload this. So the beautiful part is we work seamlessly now with Google Forms. So if I come down here for this first question, I can write something like solve for X. And if I do that, now over here you might notice this magic little blue button. So if I hit the magic little blue button, it's going to come up and bring all my EquatIO options up here. So now I can just pop the same thing open. It's the same exact experience that I just had in Google Docs. So I have prediction, I have my handwriting recognition, my speech as well. But let's say I want to do like x squared plus 4x plus 4 equals 0. And so I'm going to insert that and have my students be able to solve that. I just click the button, it does this magic making math, and then inserts it directly into my question. So now it's no longer an image, it's actually directly into my question. If I look here and I see where it pops up, now I can say solve for X, I can give directions, and then I have my math part here. Magic. So I'm going to answer this now and just show you how the beautiful part is. Anytime there's a short answer, on the student response side, yes. Now they can click on this little button and insert math as a response. So I think that that is super cool that I can insert my math there as a response, and I can choose my method. So I can answer by audio, I can answer by handwriting. We'll see if my handwriting wants to do well for me here. But I can pull it up to get more space, and then I can even just try to solve it. So I know that that's going to be x plus 2. Whoa, that was bad. X plus 2 squared equals 0. Wow, that's definitely not going to think that's a 0. And I can come down here in another line, yes. So I can then show multiple lines of work and say that this is going to be x minus 2. And so I have those 2 lines of thought, and I insert that math in there. Granted, I skipped a line, but I would have put the x plus 2 times x plus 2 in parentheses. But now when I submit that, the students can see that, and they can actually communicate a little bit more of their thought process. When I come back to this response part, then I can actually see that as my solve for response. Magic. I think that's so amazing. I love it. So now I can actually have students respond with math to a Google form. So everything's built on normal Google Forms, and as long as they have the extension installed, that they can do that. And then another component that I'm really excited about is multiple choice. So I might say something like, which is greater? And now, if I want, I can have like option A, and for the inside the options, I can actually click on here, and I can give some different options. So let's say I want to do 1/3, and then I'll insert that component. So that'll be the choice for option A, and then I can do option B in here if I want. So I'll do option B, and I can click on that, do a voice one. Let's do a voice one. 0.56. And so I can insert that, and then let's maybe do one for a handwriting option. So option C. We'll click in there and see how my handwriting can go on this one. Let's do 3 over that was supposed to be a 4, but that didn't go very well. We'll do 3 over 4x just to show that there's a denominator in there, a variable in the denominator. Awesome. So now when I go to my form and I reload that form, automatically the students are going to have the So if they didn't have EquatIO installed, the only thing that would be different would be there'd be no box to put math, so that'd be, you know, sad for them. But you can see all these different options now. I might have my math in my options. So multiple choice, there's, you know, a necessary evil, but now we don't have to just only use that as our forms options. So in here, if I want, I could say x minus 2. Let's go back. Let's do x plus 2. So I can edit either way there. I can say x plus 2. And then, I don't know if our new line component works yet. New line. No, it didn't work yet. But I can put in a new line if I want. And I can say, oops. X equals negative 2. And so I can literally do a new line component. Just like I would compose an email, I can actually, oops, I should have put that equals 0. Either way, and let's go with, we'll say, we don't know what X is. So now I can submit those parts. So now my students can easily create and communicate their thought process for formative assessments. I just think how beautiful would it be to have all of those in here. Or even like if I did a quick multiple choice thing, I can actually see easy ways that they could, if I had multiple choice. But I think how beautiful this is going to be for, I usually do warm-up problems at the beginning of class. I can see how many people are on the right train of thought. And then I can actually go into the spreadsheet and see which students are not on the right train of thought and follow up with them. So those are the things that I'm really excited about incorporating into Google Forms, Google Docs, and really being able to make math digital. Along those lines, before we get to the questions, I wanted to jump in and talk about where we're moving forward. So this is going to launch on April 4th. And after that, we do what's called these monthly sprints, and we should be adding features almost every month. And we have a really big feature coming. I know this is super awesome. I'm excited about this, and we have something even bigger coming this summer before you're back to school in August. And so what is this going to be? What I'm talking about, it's going to be this rich math workspace. It's going to have real-time collaboration, so you and a student or students can work on the same digital problem at once. We have some awesome geometry things coming. You'll be able to insert just the handwriting and not the recognized component. We'll have some graph components. You can do sketch diagrams, visual manipulatives for younger students like tangrams, place values, all these other like things that from now on, like I feel like I was a high school teacher, I feel like we have high school pretty well covered, and my goal is now developing for like a third grader. So if a third grader can make the math really easily, that's what my goal is to be able to make that happen. And then everybody above there and below should be able to be, that's my sweet spot with everything in my thought process is can a third grader do this. Sheets and slides integration. So Google Slides is literally the next thing on our to-do list. I can't make promises, but I really think it can be done before the end of your school year, unless your school year ends in April. And then another thing that we're going to be on the, as a Chrome extension, we can work in other websites. So that's why it's no longer GMath as well. It's not just Google and not just math. We're going to work in other places. And if we encounter non-accessible or inaccessible math on other websites, we will make it accessible. So if you need to send some students to Khan Academy or Wikipedia, or if they go there on their own and they need those accessibility tools and they're not there, we will make that math accessible. So we'll help read and write to be able to make those accessible if they aren't currently. So that's where we're heading, and I'm super excited about where we are and where we're moving forward to, just to be able to make math digital and really incorporate and utilize all this technology.